What is up, everybody? Welcome to 5.2 Logarithms and Properties of Logarithms. Um, this is basically 5.2 and 5.4, but I'm just joining them all into one lesson because I think that works better than having logarithms on one and then properties of logarithms on another. So, what's a logarithm? A logarithm is a logarithm base b of a number n is the exponent raised from a base b in order to obtain the number n. That might seem confusing, but we have there's a triangle. I should have pasted the triangle in here, but basically, um, logarithms, roots, and powers have a relationship with each other. So a to the b is equal to n, right? If a to the b is equal to n, log base a. Now the reason why it's called log base a is because that's the base of the exponent, right? Log base a of the answer is equal to b. So log base a of whatever your answer is equal to b. So a to the b equals n. Then you rearrange, you kind of switch the n and b, and you put log in the beginning. So log base a of n is equal to b. We're going to do a lot of practice. Calculate log base 3 of 1 over 27. So how's this going to work, right? So first of all, you identify the base, and log base is 3, so the base of the exponent is 3, right? And then the answer, so the bottom's the base, and the top is the answer. That's equal to 1 over 27, right? And then you can put the x over there. So 3 to the what power equals 1 over 27? Well, 1 over 27 is equal to 1 over 3 cubed. And 1 over 3 cubed is, if you take the reciprocal of 1 over 3 cubed, you'll get 3 negative 3. So 3 to the x is equal to 3 negative 3. So x is equal to negative 3. So the log base 3, 1 over 27, is negative 3. Next, log base 2 of 2 times the square root of 2. Now this might seem a little confusing, but first of all, we're going to set up the base equation. So 2, right here, 2 is the base, 2 to the x power is equal to the answer, 2 square root 2. Now what's square root 2? Square root 2 is also known as 2 and a half power. 2 to the power of 1 half. So 2 times 2 to the power of 1 half. So this 2 automatically has a 1 power on it. So 2 to the 1 times 2 to the power of 1 half is, you add the exponents. So 1 plus 1 half is equal to 3 halves. So the x is equal to 3 halves. Next, log base 6 of 216. This is simple enough. Base is 6. Answer is 216. What do you multiply by 6? How many times do you multiply by 6 to get 216? You multiply 3 times. That is it. You're allowed to use a calculator. Right? For this one, I just put log 10 to the 6th power. But log 10 to the 6th power is basically just, it's log base 10. Right? If you see log right here, if you see log on your calculator, it's log base 10. So log base 10, let's just put the 10 down here. I'll put it in a different color because you normally won't see this. Log base 10 of 10 to the 6th power. And log base 10 of 10 to the 6th power is, so the base is 10, the x is equal to 10 to the 6th, which is the answer. So right here, beautiful, because we got the same base, x is just equal to 6. X is just going to be equal to 6. There you go. Amazing. Right? So, we're going to do, oh yeah, natural logarithms. Now, last lesson I already told you something that's natural normally has something to do with e. So, natural logarithm is log base e. and it's normally denoted by ln. So ln of e is equal to 1, right? What ln of e to the negative 2? Ln of e to the negative 2 is negative 2. It's just negative 2 because you put e down here, right? Log base e to the x is equal to e to negative 2, and then x is equal to negative 2, so it's just negative 2. And then same thing for this one, 2.5, e to the x is equal to e to the 2.5, x is equal to 2.5. Simple concept. Is that it? Okay, next. Properties of logarithms. I'm going to introduce a lot of them at once, and we're going to have more and more practice with them over time. Maybe next lesson I'll put some review in there, because properties of logarithms is really important. It's like a whole new topic. It's like exponents. It's like radical expressions. So you guys probably haven't learned this yet, unless if you're in the integrated to advanced, then maybe you've learned this, but these are the properties of logarithms. So log base whatever of any number, log base whatever of that same number is 1. Log base 2 of 2, 1. Log base e of e, so ln of e is 1. Log base 4 million of 4 million, 1. Log base 0 of 0, I think that's that's 1 actually. No, actually that's undefined. That's undefined, right? But log base anything of anything is 1. As long as a is bigger than 0. A has to be bigger than 0. You cannot take a log of a negative. That's really important. You cannot take a log of a negative, right? So log base a of a is 1. Log base a, any number of 1 is 0, because if you take a to the 0, anything to the 0 is 1. So log base a of 1 is 0. Right? If you take anything to the log power of that same base, then you get the answer inside. So for example, 3. Let's do e to the ln of 3. We'll get 3. E to the ln of 3 is 3, because e to the log base e of 3 is 3. So calculate log base 4 of 4, 1. Log base 24 of 24, 1. ln of e, 1. Right? Remember, ln is log base e of e is 1. 3 to the log base 3 of 6 is 6, because it's taking a power to the same base log. ln of e cubed, well, we've already established that log base e of e is equal to 1, so log base e of e cubed is 3, plus log of 0. Log of 0 is it's undefined. Yeah, I'm sorry, it's wrong. It's supposed to be log of 1. Log of 1 is 0 minus log base 4 of 16. So 4 the x is equal to the base, to the x is equal to the answer. So x is equal to 2. It's 2. 3 plus 0 minus 2 is equal to 1. So this whole thing is equal to 1. Next, more properties of logarithms. Log base a of n plus log base a of m is equal to log base a of nm. And log base a of n minus log base a of m is equal to log base a of n over m. So this is going to be a little bit tough. First, log base 4 of 2 plus log base 4 of 8 is equal to, using the top property, we can do log base 4 of 2 times 8. We can do log base 4 of 2 times 8, which is log base 4 of 16, which is 2. Right, log base 4 of 16, because 4x is 16, and then x is equal to 2. 3 log base 12 of 6, 3 log base 12 of 288. This might be a little confusing. This is what I was trying to get. 3 log base 12 of 6 times 3 log base 12 of, no, not 3 times log base 12, 3 to the power of log base 12. 3 to the power of log base 12 of 288. So how do you combine these? Well, you add them together because remember the exponents. If you are multiplying exponents with the same base, you can add them together. So 3 log base 12 of 6 times 288, which is also 3 times log base 12 of 12 times 144, which is 12 cubed, because 144 is 12 squared, and then 3 times log base 12 of 12 cubed, log base 12 of 12 cubed. We've established that log base 12 of 12 is 1, so log base 12 of 12 cubed is 3, because 12 to the x equals 12 cubed, so it's 3. So that will give you 3 to the third power, which is 27. Log base 7 of 42 minus log base 7 of 3 minus log base 7 of 4 plus log base 7 of 2. We have a lot of log base 7 right here, but we can just combine them all into one log base 7 big function, big fraction. 42 minus 3 is 42. You can divide that by 3. We're going to use the dumb division symbol, yes. Divide that by 3, and then divide that by 4, and then times 2. Alright, we're going to use the dumb times symbol as well. That's equal to log base 7. What's 42 divided by 3? 14. And then 14 divided by 4 is 3.5. And then multiply, and then 3.5 multiplied by 2 is 7. It's 7. So log base 7 of 7, we've already established that log base of the same log base whatever of the same base as it is the answer is 1. I don't even know if you understand what I'm saying, but log base 7 of 7 is 1 because it's the same number as the answer is the same number as the base. That whole function is just equal to 1. Okay, so our final rules are log base n of a to the b power equals b log base n of a, and log base b of a is equal to log base n of a over log base n of b. You can remember these. I'll give you an answer. Okay, let's evaluate log base 6 of 24 using natural logs, for example, right? So log base 6 of 24 is equal to, you can insert any log, any n, and it will work. So I can put log of e of 24 over log of e of 6, right? I can do that. And then log of e is just ln, so ln of 24 over ln of 6. And usually your calculators actually do not have log base, so you have to manually put in the ln. ln of 24 is 3.178, and ln of 6 is 1.79. So ln of 24 divided by ln of 6 is equal to 1.773. That's roughly 1.773. 6 to the power of 1.773 give you 24. That's it. And if you ever see an exponent, you can basically just eat it out, right? If you ever see an exponent, so let's say log base 4 of 8 squared. Log base 4 of 8 squared. No, let's make it easier. Log base 4 of 6 cubed plus log base 4 of log base 4 of 6 cubed plus log base 4 of another 6 squared, right? If you want to simplify this, you can put the 3 in front, the 2 in front. You'll get 3 log base 4 of 6 plus 2 log base 4 of 6. And then you can get 5 log base 4 of 6. And that's your answer, basically. So, let's do some practice problems. Okay, 22. Why is this wrong? Natural log of 8x cubed, or ln of 8x cubed, is equal to 3 ln of 8 plus ln of x. Okay, let's do this, okay? ln of 8x cubed. ln of 8x cubed. ln of 8x cubed is 3 ln 8x. Because we've established this by this rule, we can just bring it over. 3 ln of 8x. But why is this wrong? It's because it's 3 times more ln of 8x, 3 times ln of 8x. In the parentheses, you'll have to do this, 3 ln of 8 plus ln of x. See, the converse is also true. So ln of 8 plus ln of x equals ln of 8x, then ln of 8x is equal to ln of 8 plus ln of x, right? I'm just going to say natural log now because I don't want to say ln. So this is the correct answer. 3 ln, it's supposed to be 3 ln of 8 plus 3 ln of x, not 3 ln of 8 plus ln of x. So which of these is not equivalent to log base 5 of y to the 4th power over 3x? Justify your answer. Okay, so first of all, we can just separate, right? First of all, we'll separate because there's a division symbol. The converse is true. Log base 5 of y to the 4th power subtract log base 5 of 3x. Right? And since there's 3 in x right here, we can separate it even further. We'll get log base 5 of 3 plus log base 5 of x. And then there's an exponent inside of the log, so we can transfer that to the beginning. So this is your correct answer. And which one is this correct answer? Correct answer is... Wait. I forgot to put this to negative. I forgot to put this as a minus. Correct answer is B. Next, the intensity of a sound of a certain television advertisement is 10 times greater than the intensity of the television program. Right? By how many decibels does the loudness increase? So this is the formula for intensity of a sound. So loudness. So L of L is decibels. It looks like this, and then L is intensity. Right? So no. This is I actually. I of O is intensity, right? I think, yeah. Okay, so let's say 10 log 10 over L minus. Actually, wait. Yeah, 10 log 10 over L equals minus 1 and minus 10 log 1 over L. First of all, we can separate this. Right? And log 10 is just 1. Log 10 is just 1. Right? And then subtract that by 10 times 1 minus 10 times log 1. Log 1 is 0 minus log L of O. So 0 will just get you this negative. So we will have 10 times 1 minus 0, 1 minus log 10 L minus plus. You will have 10 times 1 as your final answer, and then 10 will be the amount of decibels that loudness increase. So 10 times the intensity ups by 10 decibels, right? Ups the loudness by 10 decibels. And that's it for today. If you want more help asking the questions, there's going to be after this we're going to do 7. After this we're going to do some more logarithms. Then we're going to do chapter 7, which is sequences in series. I am looking forward to that. So that's going to be it. If you liked it, press the like button. you would recommend it to your friends who are learning logs, because it's a really simplified explanation of log. And if you want more, then ask for more. Um, in a comment, I'm kind of free right now, as I just have to do my biology final, then I'm done. So that is it.